Hello student, welcome to our channel Math with JG. Today's topic is curve tracing Cartesian type part 2. If you have not watched the part 1, the link is in the description. We recommend watch part 1 and then come to the part 2. In this video, we are going to learn example number 2 of Cartesian curve type 1. The second example, trace the curve y square into a minus x equal to x cube. Let's start with the example number 2. Trace the curve y square into a minus x equal to x cube. If you observe, the curve is in the type x and y, where the powers of x and y are natural numbers. Hence, this is the type Cartesian curve. First, rule number 1 is symmetry. For Cartesian curve, if we want to check the symmetry, we check the degree of x and y. If you observe the term of y having degree even, the terms of x having degree odd. So only terms of y is having degree even. So clearly curve is symmetric about x-axis. So as the degree of each term in y is even, therefore curve is symmetric about x-axis. Now, rule number 2 is about points of intersection. Now, let's study rule 2, points of intersection. In this rule, we are going to first check whether the curve passes through origin or not. So if possible, try to express y explicitly as function of x or x explicitly as function of y. If you observe, the function is y square into a minus x equal to x cube. Therefore, y square is equal to x cube upon a minus x. So, if we put x equal to 0, clearly the numerator is 0, denominator is a, so 0 upon a, the ratio will be 0, therefore y equal to 0. Therefore, for x equal to 0, y equal to 0, therefore curve passes through origin. In the earlier example, the curve was not passing through origin. But for this example, curve passes through origin. Hence, we will also check the tangent at origin. So, this was your first origin. Second point in this, tangent at origin. To find the tangent at origin, we'll first simplify this term by multiplying and subtracting all the terms to the left hand side, equating to 0. So if you multiply and open the brackets, we get ay square minus xy square minus x cube equal to 0. Now let's check the degree of each term. The degree of first term is 2. Degree of second term is 3. As x into y square, index will be added, degrees will be added. 1 plus 2, hence the degree of this term will be 3. Degree of x cube is 3. So we will compare the least degree term to 0. So the least degree term is ay square. Comparing, or instead of comparing, let's say equating least degree term to 0. So least degree term is ay square equal to 0. A is non-zero number, we will divide by a. So we get y equal to 0. Hence, the equation of tangent at origin is y equal to 0. Now y equal to 0 means x-axis. Now we will also check whether the curve passes through any other point. If you look at the numerator, numerator is not having any term of the subtraction of some number minus x or some number minus term of x. Hence, the curve do not cuts any of the coordinate axis. That means curve do not cuts x-axis or y-axis. So, in rule 2, point of intersection, the curve passes through origin, and the equation of tangent at origin is y equal to 0. Now, rule 3, asymptote. To find asymptote, we'll consider the equation y square equal to x cube upon a minus x. Now, if you observe again the denominator, so as x tends to a, if you put x equal to a, denominator will be 0. Therefore, as x tends to a, y tends to infinity. Therefore, x equal to a is vertical asymptote. X equal to a is vertical asymptote. Now, rule number 4, spatial point. For spatial point, first we'll go to rule number 2. If you observe, curve passes through origin. If you look at this term, x cube, the degree of x is 3. That means 0 appears 3 times. Y equal to 0 appears 2 times. So common point that 0, 0 appears 2 times. Hence, 0, 0 is double point. So, as 0, 0 is double point, we will check the tangent. So, if you observe the tangent at origin, we get only one tangent. So, if a point is double and we get a unique tangent at that point, then that point is called as cusp. If the point is double and if we get unique tangent, there is single tangent at that point, then the point is called as double cusp. That double point is called as cusp. So 0, 0 since 0, 0 is double point and tangent at 0, 0 is unique, therefore 0, 0 is cusp. Now, the last rule, region of absence. For region of absence, we will find out the value of y. If you look at y square equal to x cube upon a minus x. Therefore, y is equal to square root of x cube upon a minus x. Now, we know that the square root does not exist if the number is negative. As the number is a ratio, so ratio is negative if one is positive, one is negative. So, we have two cases. If we take x is negative, that means numerator is negative, clearly a minus x will be positive as we are subtracting negative number from a. So the result a minus x is positive. Hence the denominator is positive, numerator is negative, therefore ratio is negative. Hence y is imaginary. Therefore no part of curve lies as it is less to left of x equal to 0. Similarly, if we take another case for denominator negative, that is a minus x negative, that is a less than x, that is x greater than a. So for x greater than a, numerator is positive, denominator is negative, hence the ratio is negative, therefore y is imaginary. As soon as y is imaginary for x greater than a, therefore no part of curve lies to right of x equal to a. So this is the description of the tracing of the curve in this example based on these 5 rules. Now let's draw a rough sketch based on the information we have written. Let's draw the rough sketch based on the information we have written in this. First we'll go to rule number 3. If you observe asymptote, x equal to a is your vertical asymptote. So we will draw a line parallel to y-axis at a comma 0. So this is your x equal to a vertical asymptote. Asymptote means the curve will touch this line at infinity. So whenever we are drawing, it will approach, reach to the point, reach to this line, but it will never intersect or cut this line. Now coming to the rule number 5. The curve remains absent for x less than 0, x greater than a. So the curve will be drawn only in this region. Coming to Rule number 4. If you observe 0, 0 is double point, that is cusp. Hence, the nature of the cusp is like this. And the nature of the node is like this. So if you observe the point is cusp, hence we can draw the rough sketch as here the nature will be like this. As x equal to a is your asymptote, it does not cut this curve, hence the rough sketch is like this. As it is symmetric, the same part will be on the left hand side, below the x-axis. So this is your asymptote, this is your origin, and the rough sketch of example number 2. So this is the end of part 2 of curve tracing. I hope this part is useful for you. In the next video, we'll be continuing this part, that is the third example on the Cartesian curve only. If you liked our content, please like the video, share with your friends. If you have not subscribed, please subscribe our channel for more videos. Thank you.